So, in this problem, we're asked to determine the couple moment acting on the pipe shown below. So you can choose any point on the pipe to do this analysis, and then you can use either a scalar or a vector analysis. Um, for this problem, we're going to first start off. We can use the scalar method, and then we can check our results using the vector method. So the scalar method for a couple moment, is going to be equal to F times D, where D is the shortest distance between our two coupling forces. So in this case, our moment would be equal to F, which in this case is equal to 25 pounds. And then the shortest distance between our two coupling forces would be from point A to, I'm going to call this point C here. Alright, so what that's going to be equal to is going to be 25 pounds times 6 inches times the cosine of 30 degrees. Alright, so what that'll end up being is we'll get our moment is going to be equal to 75 times radical 3 pounds, which is approximately 129.90 pound inches, which is about 130 pound inches. Alright, so that's the scalar method. So that was really nice and simple. Granted, this is a scalar number. If we want to determine what the vector is due to our couple moment, what we have to do is we have to use the right hand rule. So using the right hand rule from point A to point C and going along the direction of our force, what we end up noticing is that our moment would be going along the negative y-axis, so we have to include a negative sign to our 130 pound inches, and we see that has to be perpendicular with our moment arm, which is going along the x-axis, and our force, which is going on the z-axis, so that means it has to be our y-axis in this case. Okay, so the second case here is the vector analysis portion. So we can check our methods using the vector method. So for the vector method, we would get our moment is going to be equal to what I'll say is RAC cross FB. So we can plug in our values. Sorry about that. Into this determinant equation. Alright, so if we do that, the direction along the x-axis, we would get 6 inches times cosine of 30 degrees. Our y direction would be 0. Our k direction would be 0. And then we can copy those first two values along the left-hand side of our equation. On the right-hand side. So we get 6 inches times cosine of 30 degrees. And then we get 0 as our last term. And then for the final row, we would just have to include our force at point B, which was just 25 pounds along the positive z direction. Okay, so if we look at this equation, we'll take our diagonals, and what we'll notice is that all of our positive diagonals will be equal to 0, and then our negative diagonals will be 0 except for 1, alright, which we would get our moment would be equal to negative 25 pounds times 6 inches cosine of 30 degrees times J, which would just be equal to minus 130 pounds inches J. All right. So to conclude, you can use either method, whatever is more comfortable for you. You can use either the scalar method, which you can just find the magnitude using force times the distance, and then you can use the right hand rule to define its direction, or you could use the vector method, where you can define the RAC and FB as Cartesian vectors, and then you can evaluate the cross product using the determinant, and you can solve for the moment that way. So either method is fine, whatever one you're more comfortable with.